Okay, we're on part 3 of 3 parts about the Pritikin papers that say high carbohydrate diets are best. And when I say high carbohydrate diets, I also mean and very low fat diets. Pritikin meant that. He meant 80-10-10. 80% of the calories from complex carbohydrates, meaning starches, 10% of the calories from fat, and 10% of the calories from protein. Okay, so here I want you to hear what Pritikin says. He says, excess fats, whether animal or vegetable, create damage in 3 ways. They interfere with carbohydrate metabolism, meaning they cause insulin resistance, and they cause diabetes. Oops, my little background towel on the chair fell. Elevation of cholesterol and uric acid in the plasma. Uric acid, by the way, is a bridging molecule. It also sticks red blood cells together, causing rouleau formation, blood sludge, increased risk of clotting. And they produce tissue anoxia. Okay. Let me actually show you. I summarize this myself here. So basically, here's all the problems and some of the main problems with fat. High-fat diets are always bad, okay, for any regular person. If you got refractory epilepsy that you can't control with a medication, maybe you can slow your brain down with a high-fat diet. But other than that, there's not too many reasons why you ever want to eat a high-fat diet. Saturated fat and omega-6 cooking oils, PUFAs, polyunsaturated fatty acids, they cause blood sludge, rouleau formation. They stick the red blood cells together, and that causes tissue hypoxia. Okay, so you don't want that. Let me try to shrink myself here. I'm trying to get myself here. Trying to shrink my little corner down, then it'll be better. Okay. So what I'm saying here is there's a lot of reasons why fats are bad. The next one is the thick blood. When you thicken the blood, that means you're pumping a milkshake up to the top of your brain. That's the hardest spot to get to, pump it against gravity, the top of your head. So pressure has to go up when you're pumping thick blood like a milkshake instead of pumping thin blood like water. The next thing is the same thing that stick red blood cells together, they tend to stick the platelets together. Increased platelet aggregation can also be caused by dietary sodium. When you get increased sticky platelets, platelet aggregation, they can also stick around metastasizing cells that are associated with increased risk of metastatic cancer, because sticking to the outer surface of a metastasizing cancer cell in the blood will hide it from the immune system cells that remove the cancer cells. Because the way the immune system works, it's like Braille. It feels the cells as they go by, and it can't feel the cancer cell if it's covered in platelets. So you're increasing your risk of cancer spread. You're also increasing your risk of clots, because platelets cause things to clot, to stick together. You get insulin resistance. All fats increase insulin resistance, especially sat fat, but they all do. So you increase your risk of diabetes. And diabetes leads to all kinds of downstream problems. Increased insulin leads to increased insulin-like growth factor, leads to increased activation of mTOR, leads to increased risk of cancer. Okay, diabetes plugs up arteries all over the place, in the brain, in the foot, everywhere, in the Johnson, in the heart. Also, high-fat diets are associated with increased incidence of leaky gut. They tend to be low-fiber diets. Most of this fat's either going to come from animal foods, or it's going to, which have no fiber, or it's going to come from processed foods, which have very little fiber, or it's going to come from oils, which are also toxic to the gut lining. When you get leaky gut, you get increased postprandial endotoxemia, bacterial endotoxins, and those cause amyloid clotting, make the blood more prothrombotic. You get increased incidence of autoimmune disease. They're uncommon, but they can be really bad. You get increased, besides the increased postprandial endotoxemia causes activation of the brain microglia, because when you have leaky gut, you tend to have leaky blood-brain barrier, and you can get bacterial endotoxins like LPS, lipopolysaccharide, and LTA, lipoteichoic acid, across the blood-brain barrier, causing activation of your microglia, the macrophages in the brain, and those will then release harmful chemicals, because they've got PRRs, pattern recognition receptors. When they sense LPS and LTA, in the way they work, that means there's bacteria present. So they release toxic chemicals, reactive oxygen species, things like inducible nitric oxide synthase has been activated. So you get way too much nitric oxide. And also these inflammatory cytokines and whatnot. And that's to sterilize the adjacent area from what they presume is a bacterial infection. That also, by the way, causes activation of something called the quinolinate pathway, the kynurenic pathway, and that's another excitotoxin. So all these things contribute to the destruction of neurons and result in cognitive decline. The omega-6 fats are bad. We went through this before in previous lectures. The Tetsumori Yamashima, Japanese neuroscientist guy, lipid peroxidation, hydroxynonenal, toxic aldehyde theory. He also calls it the Calpain-Cathepsin theory of neurodegeneration from omega-6 cooking oils. He felt that that was the main reason why more Japanese are becoming demented, because they've westernized their diet with a lot more fried food and oils. Okay, then people say, well, what about omega-3 fats? Those are good. Those are the saintly fat. Those are the blessed fat, the unique fat, the only good fat. It has a slight anticoagulant effect. But what I'm saying is omega-3 fats are also bad. Omega-3 fats, anything you eat fat, it increases your risk of obesity. It increases your risk of insulin resistance. Omega-3 fats, you can real quick look, you'll find 3 papers on increased risk of atrial fibrillation, and one paper in particular was almost double the risk, like 1.84 times increased frequency of atrial fibrillation in people on omega-3 fats. Immune suppression, suppresses your immune system. You don't want that. That makes you more vulnerable to cancer. It makes you more vulnerable to infections. They're known to increase the risk of prostate cancer. Well, prostate cancer tends to go hand in hand with breast cancer and uterine cancer. Anything that increases prostate cancer tends to increase breast cancer. I don't know for certain if it does increase breast cancer, but I can tell you it's been shown in several papers to increase prostate cancer, so I would expect there's a good chance it'll increase breast cancer. In animal studies, it showed because it was thought because it suppresses the immune system, it was associated with increased metastases to the liver, for example. So I don't supplement with omega-3 fats. In my opinion, that's not a good idea. You get plenty of omega-3 fats just from eating plant foods. So what I'm trying to say is you can't win with fats. The only good fat, in my opinion, is just eating the fiber, because that gets converted in part to short-chain fatty acids. And you'll automatically get a little bit of omega-3s and omega-6 essential fats just by eating low-fat plant foods. Okay, so I wanted to clarify that up. Okay, now we'll go through a little more of what Pritikin was talking about. Pritikin then said that, okay, one of the first guys to show the anoxia caused by a high-fat meal was Roy Swank. Roy Swank is a famous neurologist, friend of Dr. McDougall, who would feed hamsters a meal of cream. So that's going to be a lot of sat fat, like milk. And then he would look at their cheek pouches, and he could see that they would get plugging up of their capillaries from the chylomicrons sticking the red blood cells together. So chylomicrons elevate in the blood quite quickly, and subsequently you get increased cholesterol, LDL cholesterol, and whatnot. That's also a bridging molecule sticking red blood cells together. So at 3 to 6 hours after feeding the high-sat meal, you got extensive blood sludge and plugging up of capillaries. And he saw that the oxygen level was decreased to 68% of the starting value. So that's bad. Okay. So basically he's talking about a 32% drop in the oxygen level in the blood. Okay, it took 72 hours. 72 hours. That's a lot of time, man. To like 3 days before it came back down to normal, reached 95% of its original blood oxygen level. Okay, could such a cream meal precipitate an anginal effect? Yeah, Peter Kroll, the cardiologist from Pennsylvania, showed that with angina patients. He fed them a high-fat meal, sat fat primarily, checked their blood lipids every 30 minutes, and at peak lipemia, let's say around 3 to 6 hours, they started having a lot of anginal episodes. 14 anginal episodes occurred. Okay, the same patients on after another overnight fast, they drank a fat-free drink with the identical number of calories in bulk. After 5 hours, there was no increase in blood turbidity. You know, when you look at the blood, the plasma looks the same, transparent. There were no angina episodes, no abnormal EKG tracings. Yeah, so the low-fat meal did not cause cardiac angina, did not plug up the arteries, did not make the blood lose its transparency when you try to look through it. Okay, and then similar studies done by Ray Rosenman and Meyer Friedman. These are the ophthalmologists now. So Quo was a cardiologist. These guys are ophthalmologists. And they look at the eye with an 80 times magnification microscope. And they could see when they fed unsaturated fats like PUFAs or saturated fats, you would plug up the little capillaries in the conjunctiva. They did the test on 44 firemen with butterfat cream. Another time they gave them safflower oil and omega-6 oil. And again, they plugged up extensive arteries. The red blood cells were sticking together. It was even worse with the omega-6 oils. It was a more prolonged plugging up to the point where the lab workers were pissed off. They couldn't go home because the experiment wouldn't end. Okay, this is just a reminder, like I said, it doesn't just cause sludging of the red blood cells, it also causes sludging of the platelets. Not good. You're prone to clotting. Like I said, you're prone to clotting from platelet aggregation. You're prone to clotting from red blood cell aggregation. You're prone to clotting because you're predisposed to postprandial endotoxemia with amyloidogenic clotting of your red blood cells. That's all bad. That all means increased risk of heart attack. You don't want that. Okay, let's see what else in here. Platelet aggregation, we talked about that. Arachidonic acid is only present in animal foods. It's an omega-6 fat. It's also bad. That also causes increased platelet aggregation. So that's another reason that these high-fat meals or these animal food meals will cause increased clotting. Amyloidogenic clotting, blood sludge of RBCs, blood sludge of platelets, arachidonic acid, and leaky gut-related amyloid clotting. Okay, soybean lecithin, another type of fat, also did essentially the same thing, was plugging up capillaries. This time they studied it in the context of the lung and lung functions. And you can do the same thing in rabbits with the lecithin, severe impairment of capillary gas exchange. A guy named Perkel, a pathologist, confirmed the Hazlitt experiment in the lungs, and he had some young people who died suddenly in their 70 to 40 years old. So when somebody dies suddenly, you always think of a heart attack is the most common thing. But he was showing some patients who died because it was plugging up pulmonary vessels, according to this paper here. Okay, and so that's it from the stuff in the Pritikin paper. And here's the references from the Pritikin paper. Again, you can get this at drmcdougall.com. It's the February 2013 newsletter about the work of Pritikin. And a lot of these are real famous landmark papers. Pritikin was a great genius, and he would describe and out things in a very accurate, concise, easy-to-read form, very logical. It's easy to follow Pritikin when he writes. Okay, here's just more of the references from the paper. These are, like I said, a lot of these are famous papers, like Swank's work, Peter Quo's paper, Meyer Friedman, Ray Rosenman paper. Okay, it's all great stuff. So anyways, the point of this whole thing, why did I get kind of excited about this and want to make this talk? Because I'm trying to tell you, low fat is the best you can do. Because I've had a lot of people ask me, well, you say low fat diet is the best, but other people say moderate fat or high fat diet's better. And when I'm basically saying I'm right, they're wrong. Here's a bunch of references to prove it. Common sense correlates with what I'm saying. The history of nutrition correlates with what I'm saying. The work of Kempner, the work of Pritikin, the work of McDougall, it all correlates with what I'm saying. The logic of it, the biochemistry of it, it all works. So anyways, I hope that was helpful.